Good morning everyone, I am Mr. Ish. You are joining me for this video and I thank you. Let's take a few minutes and understand what's going on over here. Is this reaction a redox reaction, reduction, oxidation reaction? And that right there is just the question. Nothing too out of the ordinary here. We have NaOH plus lead chloride. We don't know which direction equilibrium will take, but we're not worrying about that. Giving sodium chloride and lead hydroxide. The fact that you have a 2 over here tells you have an oxidation state of lead in terms of +2. You would have a 2 over here because hydroxide anion is always -1. Then you would start by balancing it. You put a 2 here, and everything looks good. The best way to determine that is start looking at oxidation states of each item. When you're looking at sodium over here, you're looking at a +1. When you're looking at hydrogen, it's a +1, and oxygen is a -2, hence there's a 0 net charge. Over here you have a -1 from the 2 chlorines, therefore this is a +2, nothing out of the ordinary. Here you have a -1, +1. Here with regards to the hydrogen you'll have a +1, +1. With regards to the oxygens you'll have a -2, -2 because there are 2 of each. And then look at it, you have a -4 plus 2 is a -2, therefore lead must be +2. When you're looking at sodium over here, it's going from a +1 and it stays a +1. When you look at oxygen, it stays from -2, never changing to anything other than -2. Hydrogen here is always +1 to +1. Lead goes from +2 to +2, and then chlorine. In all instances, as you see here, for chlorine it's -1 and staying -1. What we see over here is a reaction which would seemingly look like a redox reaction simply because we think in our minds that there are metals involved over here and they'll change oxidation, but nothing changes over here with regards to an oxidation reaction. And perhaps I can tell you why that would be the case, why something like this, which you would think to be an oxidation reduction reaction, is not. It's just a seemingly non-redox reaction, and the reason is this. If this reaction were being carried under water or in water as a universal solvent, you know in that instance lead chloride is a solid. Lead hydroxide is weakly soluble, but you can assume it to be relatively soluble in water. The main solid or precipitate would be this. You would have spectator ions that you would see, and remember here I'm talking about universal solvent water, just temporarily, and then I would have 2 Na plus 2 Cl minus. Assuming this to be soluble, we'd have this. In this instance, the spectator ions would go out of your basic reaction. Here it would go out, this would go out. What would really remain would be this in terms of a reaction, would be exactly in this direction towards a generation of this precipitate. You'd have 2 Cl minus chloride anions and then this reacting. But look, in all instances over here everything is still the same with regards to the oxidation state. The net ionic reaction shows nothing other than an association or dissociation. If supposedly you want to do double arrow, you have association dissociation reaction only. Everything over here is disguised as the basic reaction over here. When we're looking here at everything with regards to sodium hydroxide being the basic solvent, look how everything changes. In that instance, when you're looking at acids or you're looking at bases with the presence of metal salts, what was generally insoluble in water becomes soluble. You would have spectator ions, sodium ion, hydroxide ion. You would have lead ion, cation, you'd have a chloride anion. Because this would become soluble in a solvent like that, you'd have 2 Na plus 2 Cl minus. Of course, we are assuming this to be entirely soluble because it would be in the presence of a base. This is exactly what you'd see. Here everything is a spectator ion. When you look at the net reaction or the net ionic reaction, there is no net ionic reaction, because everything is just dissociated into anions or cations. There is no net ionic reaction. Since there's no net ionic reaction, this reaction is nothing other than a disguised reaction representing everything in a dissociated state, everything present in the solution as free species. And that right there is why this is not a redox reaction, because no true reaction is occurring. You just have a mixing of anions and cations, and that's about it. But that right there was all the content for this video we want to address. Thank you for watching. Have a good day.